The GC algorithm for mark and sweep is in some sense a completely general algorithm, but there are different ways to implement the notions of marking and sweeping. And so we'll look at one other way of implementing this instead of having this free list and an explicit sweep pass called a two-space approach. And the way a two-space collector works, the main advantage of a two-space collector is that allocation is way easier. We get the very simple form of allocation that we saw in our most naive allocators last week, which is you just have some memory, and when you want to allocate something, you just gather enough bytes to satisfy those allocations. Eventually, you use up all the space you have because you're not freeing anything. And that is, of course, when we trigger a garbage collection. So at the point that we get here, among all of the allocated blue blocks there, only some of them are actually referring to live pointers at this point. But the way a two-space copying collector works is that it doesn't go figure out these live pointers first and then try to free the space in between. What it does is, as it discovers a live object, it's going to copy that live object over into a new contiguous region of memory. Right? So it's called a copying collector because instead of leaving the live objects in place, it's actually going to move the live object to a new spot. The advantage of this moving is that you can see all of our allocated memory is all squashed back together now. So we get good locality by moving live objects back all together if they got spread out by other intermediate allocations. A consequence of moving things, though, is that we need to be able to update all of the references to the objects. And for example, this is why a conservative collector cannot be a copying or do any form of compaction, because it's guessing about which things are pointers, and if it accidentally moves something that was supposed to be a number, then it would change the numbers in the program. Right? But when we have precise information about variables that are supposed to be pointers, then we can do this kind of compactioning through copying. Once the allocator has moved all the live objects out, then it can keep allocating here, and when it runs out of space, it can go back and copy things back to this other side. So that's why it's called a two-space. We have the new space at all times that we're allocating into. When we run out, it becomes the old space, and the other one becomes the new space. So to space and from space are other words for those two spaces, and the coloring gray process that corresponds to copying from to space, copying from space to to space. Let's look at this using a similar picture as before. So we have that same state of the machine, but this time it's going to be a two-space collector. So when I find live objects, instead of setting the color here, I'm just going to copy them over to here. So that first step, where we would have put a gray color on this object, now we're copying that object into the to space. All of its pointers still refer to the old space, but we've updated this pointer that we used to discover that object, the one in the variable, we've updated to point to the new copy over in to space. So anything that's over here corresponds to gray. That means we can just walk through the objects that are in this space to pick a new gray thing and iterate through all the grays. So the green pointer here is just going to walk left to right, top to bottom. When we've picked this as our gray node to consider, we will follow each of its pointers. These two pointers are pointing to white things because they're still in the from space, and so we're going to paint them gray by copying them over. So we've copied those two objects over. When we copied them, we also added this forwarding pointer, and you'll see what that's for later. So we make the old from space objects point to the copies in to space. But the to space is ultimately going to be our view, and you can see that we've reconstructed the reference from a variable to an object and to its children. And now we're done with this gray object. It's painted black implicitly by moving the green arrow forward. And so now the green arrow is looking at this gray block. It doesn't refer to any other objects, so we paint it black and move on to the next one. Here we have a gray object that refers to another white object, so we will copy that other object over, leave a forwarding pointer, and now we're done with this object. We can paint it black. Consider this gray object. It has a reference to this other object, but now you see the point to the forwarding pointer. So something has to say over here in this to space that in this from space that we've already copied it over. It's always gray, and the place that we copied it to is given by this forwarding pointer. So we're going to change this blue arrow here to point to where the purple arrow points to. It'll point back up that way. And that's all the references of this object, so we're done. we paint it black. And that is the last object here. So at this point, we don't really have to do any extra work. We just have to forget the from space. Right? We don't actually have to zero it out like that. We just stop paying attention to it. And now we have our new updated view here, which has the same topology that we got by doing a mark and sweep before.